So, today we are going to do our review for the Unit 2 test. There was a lot in Unit 2. A lot of new code for you guys to understand some fundamental pieces in Python. Let's go through and take a look. The first lesson was on for loops. So, for loops, make sure you know the basic syntax. So the basic syntax of a for loop is we have the word for, we have some type of variable that will hold the numbers, we have the command in, and then we have a range. And the range, if it has a single number, then it's going to be assumed that it's just starting at 0, going up through 2, not including 2. If it starts at say it starts at 3, 5, then it'll go from 3, 4. So that way it doesn't include the last number, but it doesn't start at 1. We can also do steps to get it to count through our loop. One of the things that people forget all the time is the colon, so make sure you have included the colon in your syntax. In addition, this is the first time we're really talking about tabbing in where it matters. You need to make sure that you indent every statement that's included in the for loop. One of the comments I said you could probably do would be to put in a hashtag comment at the end of the loop so you know where the loop ends in code. That was one of the documenting things we talked about. So a colon starts the loop, putting in a comment that says this is the end of the loop will help you reference that indenting to make sure everything's indented at the same level. We use this to build up measures of music, and one of the things that we talked about is staggering the music. So in this case we're not staggering the music, but we are going from a measure to a half measure. When you're staggering the music, if I have an example of that. I didn't have an example of that. When you're staggering the music, you're counting by every other value. So when you do your range, you want to include a value that is that third parameter. So for example, if I go from 1 to 50, 2, then the loop will count 1, skip 2, go to 3, skip 4, go to 5. So when it's putting in your measures, it's putting them in every other measure. That way we can get some interesting effects into our audio that we didn't do before. The other thing that was inside this is when we talked about incrementing and decrementing. Sometimes you put a counter inside of a loop where you want to increase something. The command to do that could be either measure equals measure plus 1. But in computer code, in pretty much most languages, most modern languages, we've replaced measure equals or assigned measure plus 1 with the command measure plus equals 1. And that means to take the value that's in measure and increment it by 1 and put it back in measure. Measure minus equals means take the value that's inside measure and decrement it by 1 and put it back inside of measure. So that was lesson 1. So in lesson 2, we talked about adding effects with loops, so using that set effect command. And really, it's just a continuation of the previous lesson, and we're looking at using the loops to set up our media, but then also do our set effect, where we're using some type of calculation or some type of formula to figure out what our set effect should be based upon the counter that we are in the loop. So in this example, they created something called a pan amount. That's the variable that's going to keep that value, and it's going to be a function of what measure we're in, and it's also affecting the track. So we're going through 3 different tracks here, and depending upon what track we're in, it's going to set the pan amount. So it's doing a calculation. The formula is irrelevant. You can come up with any formula you want. They just came up with this formula where they do 200 times track minus 1 divided by 3 plus 100. You can come up with any number you want. It doesn't matter how you come up with that calculation. This is demonstrating how you can use a value that changes throughout the loop to affect the sound of the song. So here's another example where we're looking at a range and we're applying this through a measure, and we're taking our set effect and making it go from measure to measure plus 1. So we're changing the volume for each of those different measures. And that was the assignment. So that was it for lesson 2. Really just an application of lesson 1. So for Unit 2, Module 2, Lesson 1 and 2, we were talking about dividing our song up into functions. Section 1 talks about looking at the way a song gets built in different sections. And we actually very quickly dumped the idea in Section 1 because Section 1 literally copied and pasted code like 3 times. So we took some section, called it the chorus, and we had a section maybe called the melody, and we just repeated that section A, B format over and over and over again. And it was a lot of cutting and pasting. We decided that was really not a good way to go. And then we came up with the ability to define custom functions. So this is a very powerful ability, and we'll take a look at this code. So this is the structure for defining a custom function. You have to use the def command. You have to name the function in some way. Call it whatever you want, but we discussed in documentation that the name of the function makes sense. It should match what the function does. That limits the number of comments that you have to add later. If the function just says, instead of saying function name, it says build the chorus or build the melody, then that function will make sense and we'll know exactly what it's supposed to do without having to put in a comment. It takes as many parameters as you want. When it's in the definition, the variables are called parameters. When it's in the function call, down here, the values that are passed to the function are called arguments. So make sure we have those words correct. When we're actually using the function, we're sending values through the arguments. When we're defining the function, we are setting up the parameters that will receive those arguments. So it's two sides of the same coin, but we do have two different two vocabulary words for those. Again, the colon is important. We learned that the colon in Python marks a beginning of a block of code. This is going to be consistent throughout Python. We saw it with the for loop. We're looking at it now with functions. Later on, we'll see it when we start talking about conditionals. The colon marks the beginning of a block of code, and anything indented after that will be part of that block of code. Again, after these commands, I would put a hashtag comment that says end of function, just to let yourself know that this is the end of the function, making sure that's indented as well, so it's part of the function. Makes it easier to read, it makes it a little bit cleaner and clearer, and prevents you from making mistakes. This is a very big source of mistakes, people forgetting to indent. They define their function, they don't indent the statements, and then they're like, wait, why is this not actually doing anything? Well, because, or causing an error, worse yet, because you didn't indent. So that indent point is really, really important. It's one of the main concepts that we're learning here in Unit 2, that when we're indenting blocks of code, that we have to make sure we consistently indent. And I would use the tab key, not just spaces, because spaces sometimes you can miscount and it's hard to see, is it 4 spaces or 5 spaces, and it can throw off your indenting. So if you just use the tab key, it's pretty clear that you have indented. But theoretically, you could use space. You could just do a single space to indent. It doesn't have to be a tab, but tabbing is just easier to work with. So we got in the habit of defining our own functions, and this is what it looks like. And then we called it, and then it built our part of our song for us. So one of the things we talked about in this is called scope. Anytime we define a variable or use a variable that's inside of a function, it stays inside that function. No other part of the code can change that variable. It's not associated with it. That's why when we call a function, we send arguments. And we're not sending the variable names, we're just sending the values that are stored in those variables when we call a function. So if we look at this code here, we're sending 1 and 17. That 1 and 17 maps to start measure and end measure. If I used a variable and called this start measure and this end measure, even though the variables have the same names, we would still just be passing the values. We're not actually matching and linking up variables. We're passing values. So it doesn't matter what the variable names are here. It just sends the numbers. So here's another example called add section, where we're calling this function called add section. These again are called arguments. They're sending the values to the parameters. Lead clip only exists inside of this function. So if I use the variable lead clip somewhere else, it wouldn't be associated with this. It's not linked to it. It doesn't make a difference. The reason we do that is because a lot of times these functions are built into some type of library and we can't see all the code. So we don't know the definition that they use. We don't know the variables they use. So to prevent us from accidentally using the same variable name, Python just says, well, it doesn't matter if you use the same variable name. We're going to keep them separate. So we talked about the idea of using refactoring, which is when we take pieces of code that repeat and build them into functions. And that's part of the reasons why we learned functions. So we take our idea from the previous lesson about sections of a song, and we say instead of having section A, section B, and then section A again, and pasting that exact code in twice, what we can do is refactor that and build a function for section A, and build a function for section B, and then just call section A and section B with the appropriate variable names, or excuse me, with the appropriate arguments to be passed to it. So section A goes from 1 to 5, and remember, it doesn't actually include the 5. It stops and does 1, 2, 3, 4. Then we're going to start section B at 5 and goes to 5, 6, 7, 8. Doesn't actually include the 9. And then we're going to start section A again at 9, 10, 11, 12. So it stops at 12. So that section there gets built. Then we also talked about return statements and how sometimes we want to send a value back. So if we read a value from a user, we might want to send that information back from the function. Let's see, take a look at the example of that. Find my example. Okay, so the way you would return a value here is just using the return statement. So you would return that exact value at the end, and it's the last value in the function. And we talk more about this in the next lesson, but I just want to mention it here. All right, so that's the end of lesson 2. Module 3, there was a lot of talk about copyright and recording information and memory and process. So this information I'm going to let you guys look through again. Pay attention to the copyright laws. Know what you're allowed to do and what you're not allowed to do. In essence, if you don't have permission to use a piece of music, or anything for that matter, then you can't use it. It's not legal. There is a thing called fair use, but that is a legal defense. It's not a legal right. So when you use a piece of music and you sing, oh, it's fair use, that means if somebody could sue you and take you to court, and you could defend yourself in court. That doesn't mean you could defend yourself and say, hey, no, you're not allowed to tell me that I need to take this down. Yes, they are. And then you can make a choice. Either take it down or get sued. Most of us opt for the take it down side, and we take it down. And that's how fair use usually works. If the owner of the material says, hey, that's mine, I don't want you posting it at all, rather than arguing that it's fair use, most of us have enough common sense that it costs more for the lawyer than it would for us to win. We would get more benefit out of not going to court than we would actually going to court, so we just take it down and try to find something else. So that's typically the process. The easier solution is to find stuff in the public domain, and we talked about how to do Creative Commons licenses and where to find that information. So pay attention to that when you guys go ahead and review this. Finally, we talked about string operators and the MakeBeat, and specifically returns inside of functions. So let's dive in and take a look at that again. So the MakeBeat allows us to build a sound note by note, and we learned that each symbol inside of a MakeBeat string is 1/16th note. So to get a full measure out of that, we would need 16 different symbols. In Python, we talked about strings representing a series of characters using double quotes. We've talked about this before, but we can also use single quotes. For most of us, the double quotes are probably most effective. Here's an example we looked at. We also talked about the difference between using quotes with a number and not. We're going to talk more about this in the next unit. But 5 plus 6 is evaluated to 11, whereas 5 in quotes and 6 plus quotes is evaluated as 56. That's called method overloading because the plus sign is overloaded. When it's adding numbers, it actually adds the numbers. When it's adding strings, it just pushes them together. So Python does not recognize numbers as numbers unless they're not in quotes. If you put them in quotes, Python does not look at them as numbers. It just looks at them as symbols. So we kind of have to separate that in our minds, which is different for us because everything we look at that's a number, we look at it as a number. We don't say, hey, this is a string, not a number. For us, that doesn't make any sense. But for Python, it needs to. And that's true for any other languages. Here is our MakeBeat clip. We talked about 0 being the start of the clip, minus being a rest or a silence, and plus extends that another 16th note. So if we look at this MakeBeat clip here, we have a start, and then a rest, and then a start, and then a restart, and then a rest, and then a restart, and then a restart, and a rest, and then a restart, but then we're going to extend that sound 2 more 16th notes. So this little piece right here is really 3 16th notes long. And then we're going to do a new restart, and again, it's extended a single 16th note, so that's only 2 16th notes long, which is essentially 1/4 note, right? No, 2 16ths is 1/8 note. 4 16ths would be 1/4 note. And then we have another restart. So we have a total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this won't even be a full measure. This is only 14 of the 16. We actually need 2 more. Because one of the things we learned that we have to be careful of is to get a 16-character beat string. We have to make sure it's 16 characters to encompass an entire measure. If you want it to be less than a measure, that's fine, but as long as you're aware of the structure. 16 symbols gives you 16 beats, or not 16 beats, but 16 16th notes, which would be a full measure. So every 4 symbols in this would be a beat, and we're in 4/4 time. So we have 4 beats per measure. That's why there's 4 times 4, or 16. So we have 0 plus 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 will last for a single beat. Here's an example that we looked at of how it works when we run it. The MakeBeat we talked about takes 4 arguments. It takes the clip name, the track, the measure number that we're supposed to start at. The reason it only needs a starting measure is because the length of the string is going to dictate where it ends. The longer the string, the longer it's going to go on for. And then, of course, the beat string. Then we did an example where we have our 2 beats here. We read a little for loop, and we're building our beat that goes through MakeBeat. One's a synthesizer, one's a symbol, one's in track 1, one's in track 2. And then we have our measure. We're going to start at measure 1. Then we're going to do measure 2, measure 3, measure 4. Notice each beat string is only a single measure in length. So we have 16 notes here. So that's why this all plays out nicely and ends up repeating. If this was longer, let's say you put in an extra character and made it 17, we'd end up having an overlap and there'd be an error. So we really got to be careful to make sure this truly is only 16. Later on, in the next unit, we'll learn how to do some error checking to make sure it is exactly where we want it to be when we start talking about conditionals. So we also talked about the ability to return a value inside of a measure. One of the problems, like we just mentioned, is that because we don't know exactly what measure the make string ends this on, all right, the MakeBeat, excuse me, we have to know what that string is in order to figure out where we should start the next measure. So we did a little calculation here using the rhythm 1 and rhythm 2, and we said that the end measure is going to be 3 past our start measure because we know our rhythm here is going to count out for 3 measures. So every time we say create beat, our new function here, we know we want to start it, we have our sound clip, and we have the beat string, assuming that our beat string is only 16 characters. We're assuming that for the way this function works. Maybe a comment there would be good to say, hey, this only accepts a beat string that is a single measure long. Adding in longer measures causes problems. So in this case, if it was a longer measure, we'd have an issue. Again, we'll talk more about that in Unit 3, how to figure that out, and how to sort that out. But we're assuming the users follow directions well. Put in there, and in this time we're going to return the end measure, so that way we can build the next beat after it, and we can see what the effect is. We have our first 3 measures. That's what this for loop does. And then we return our ending measure, and then we have our next 3. So the basic operation of a function that returns a value is it takes input from the arguments, and then it returns values through the output, but it can only return a single thing, a single piece of information. Whether it's a string, now string could have lots of information in it, but it's a single string, or it's a single number, or later on we'll learn about other data structures that we could return, but for right now we're limited to returning a number or returning a string. In Lesson 2 of this module, we talked about the different string operators. So for our string operators, the major one is string concatenation, where you're putting 2 strings together using the plus symbol. We have to be careful, though, because what we put in there is exactly what the computer's going to put out. If we don't have any spaces and we mean for a space to be in here, then we need to put one in. So we can add 2 strings together with a space, computer science. We use that to build up beat strings. So each of these beats are, 1, 2, 3, 4, 5, 6, 7, 8. So 8 symbols. That would be 8/16ths, or a half note, or half a measure. 2 beats. Each one of these is 2 beats. So we can use these to build up a longer sound by putting that beat string in. And just by concatenating them, we have our 3 different beat strings, and then we're going to call our make beats for the 3 different beat strings. We also talked about substring, which is slicing up a song or slicing up a piece. So we could take a beat string and slice it up, or take up a word and slice it up. Remember, the indexing starts at 0 and goes to 1 less than the length. So 0 through 8 would be for ear sketch, which is 9 letters long. That's pretty consistent. So if we wanted to slice out a string, we use the bracket symbol, not a parenthesis, it's a bracket symbol. We put where we want to start at. Remember, the index starts counting at 0. So index 10 will actually be the 11th letter if you start counting at 1. Index 10 will be the 11th letter. And then we're going to stop at 15. We're going to print the 15th index, which would actually be the 16th letter if you started counting at 1. So we have to be very careful how we handle these ranges. The other thing we talked about was len. L-E-N prints the length of a string and tells us how many characters that is, which could be useful later on when we learn how to do error checking to make sure that MakeBeat string was the right length. Is it the correct number of characters? Is it 16 characters? If it's not, then we got to worry about that. And we'll talk more about how to handle that when we do conditionals. So we can use these string operators to make a beat and then cut it up into a bunch of different pieces. That's essentially what we did. We took our initial beat and then used some for loop and some slicing to slice this up into all different kinds of beats. So the main takeaways from this lesson were concatenation, using substrings, and paying attention to the index position, referring to all indices starting at 0 in Python. So let's take a look to see what's next. In the last module, I think it was the last module, second to last module, we talked about applying a lot of the things that we learned. Practicing doing functions, practicing using our loops, practicing to do our refactoring of code, to deal with some musical repetition, to deal with some transitions. We talked about what an anacrusis is, where we start a couple beats ahead of. We had a new function that was built into this that we used. Insert media section. That was a new function that we looked at how to build a section of a song. So instead of having to start at the beginning of it, we could start at another point of the song. So we could use that maybe in contrast to doing MakeBeat, which always has to start at 0, the beginning. We can talk about doing just a section of the song using insert media section. Not quite the same as MakeBeat, but you could do something similar by starting in the middle of the song. We also did a skills check to make sure we knew how to do all of these different things inside of this final module. So this was a good practice for our ending of our unit. And then we ended the unit talking about just documentation and debugging. How do you find mistakes? What would you do to look for those mistakes? And we talked about it being in the console, looking for some common errors. If you do get an error, read the error in the console and see if you can find out what the mistake is using our list of common errors that we expect, like indentation, capitalization, missing a colon, something that is typically a typo that we can resolve pretty quickly. If it was a logical error, then we'd have to go through, hey, it's actually running, but it's not doing what we expect it to. Again, indentation could be an issue for that. It's doing something that we don't expect it to. So that is all for the test. We'll have our unit test, and then we'll start the next unit. Never stop coding.